All right, so through different conversations that we've had in the last couple days, let's fill in some of these blanks, okay? We're not going to fill in every single blank because there's some really important stuff here that I need you to get. The other stuff is to help you get there, but we're already there in some places. We're not going to write down every single thing. Fair enough? Okay? Where are the important points located that we're going to talk about today? Where are the solutions to a quadratic going to show up on a graph? They're on the x-axis. They're going to be our x-intercepts. Okay? I need to teach you some vocabulary. Some of it you already know. Some of it I need to teach you. Okay? When we're talking about solving by graphs and tables, let me take a time out just a second. We're going to talk in the next couple days about how to solve quadratic equations. Obviously, today we're solving them by graphing. Hopefully, obviously, the next day we have class, we'll talk about it by factoring, as evidenced by the title of this worksheet. Okay? Next thing we're going to talk about is solving it by the quadratic formula, and we're going to spend 2 days on that, just because I want to have time to go slow and talk about every part of that. Okay? Lots of different ways to solve quadratic equations. If you have an equation that looks like this, where there's only one variable, it's x, it's an equation, not just an expression. Okay? These answers are called solutions or roots. Anybody know why they're called roots? Me neither. No idea. Maybe the guy who created it really liked that show, okay? I think probably the show came out after. Okay. But that's a good creative guess. Okay? It was a movie. Maybe there was a show also, but I know for sure it was a movie. Okay? But how is this one different? Right here. How is that different? It's y equals, right? It's not z equals 0, it's y equals. Okay? These answers are going to be called zeros or not trees. Zeros or x-intercepts. Okay? When it comes right down to it, we're basically talking about the same thing, but they have different names because they serve different purposes. Okay? And because of that, we're going to write them slightly different. All right? As we go through the examples, I think you'll see what I'm talking about. Okay? Jump over, please, to page number 3 and look at problem number 7. Is that what I want to talk to you about? No, sorry. Jump down to the bottom of that one. We'll talk about 7 in just a moment. This is what we talked about, except I didn't tell you the real mathy name of it. The mathy name of it is the fundamental theorem of algebra. How important is a theorem called the fundamental theorem of algebra? It's pretty important. Okay? The fundamental theorem of algebra states that a polynomial equation of degree n, what's a degree? The highest exponent, good, has precisely n complex roots. So what I need you to ask me, what I need to ask you guys to do for the next couple days is today I have to introduce to you vocabulary called complex roots, but we don't actually get to that until the middle of next week. So I need you, as we go through these notes right here, right down here, I need you to trust me for a couple days. And in a couple days, I think this will make a lot more sense. And it's actually not this whole part, it's just this one. Okay? So I just need you to trust me as we go through this. Fair enough? Okay. If the fundamental theorem of algebra says that a polynomial equation with degree n has precisely n complex roots, what is the degree of a quadratic equation? What's the highest exponent of a quadratic equation? 2, right? It's x squared. So the degree would be a 2. If the degree of is a 2, according to the fundamental theorem of algebra, how many complex roots should it have? 2. What's another word for roots? Solutions, right? So we should have 2 solutions. So look at this graph right here. How many solutions does it have? Where are those 2 solutions? Where it crosses the x-axis. Very good. It's right here and right here. The explanation, however, is 2 real solutions. This doesn't have, how should I say this? This has 2 complex solutions that are real. Remember at the beginning of the year I did that foldable with you where we drew circles and we talked about whole numbers? That one, right? Whole numbers and integers and natural numbers and stuff like that. And we talked about all that stuff was real number situations, right? Okay? There's real numbers and then there's complex numbers. It's a different kind of number system. And that's what I'm talking about. We won't get there until next week. So just trust me on this one. I'll get you there next week. Fair enough? Okay. 2 real solutions. Why does this have 2 real solutions? Crosses the x-axis twice. So explain this to me then. How many solutions does this have? How many is it supposed to have? So is it wrong? Is the definition wrong? This has 1 double real solution. What in the world do I mean 1 double real solution? Let's pretend this was -2. So if I had to write the answer as x equals -2, what's the other answer? X equals -2. It's a double solution. It's itself. Okay? The other solution is itself. How many times do we have to write it? Once. Okay? As long as you realize it's a double solution. Why is it a double solution? Excellent. Crosses the x-axis once. Yep. This is 2 real solutions because it's 2 different real solutions. This is still 2 solutions, but it's the same twice. Does that make sense? Okay. So what about this one? No real solutions. Can I tell you something? It has 2 complex solutions. I'm not kidding you. It has 2 complex solutions. Just like the fundamental theorem of algebra says, it should have 2 complex roots. It does. You're not going to be able to find complex roots by where it crosses the axis. I don't want to spoil it. I don't want to spoil it. I'll teach you how next week. Dun dun dun. Cliffhanger. Okay? Why does this have no real solutions? Doesn't cross x-axis. Okay? Look at number 8. I need you to think about what the answer to 8 might be, knowing the conversation we just had about this middle graph down here. A graph that's on the previous page that we're probably not going to have time to talk about has the same factor twice, x minus 5 and x minus 5. How does it affect the graph of the function? Very good. It only crosses the x-axis in one place. Very good. Very good. Okay? Questions? We talked about number 7 yesterday. I want to show you a quick example real quick before we go and answer it. Fair enough? Turn to this page, please. It's the previous page. It's the previous page. We skipped over it a moment ago. The example that they give us says, here's a factored equation. Here's the expanded equation. If you're given the factored equation, how do you find the expanded equation? Some of you are showing me with your hands. You're like, you multiply, right? You multiply it out. You do that and that and that and that. What if you're given the expanded equation and you're asked for the factored equation? What do? You factor it, right? Okay? So if this is the factored equation and this is the expanded equation, where did they get the graph? Calculator. Okay? We'll figure out a different way here in a little while, but for now they got it from the calculator. Okay? Where did these come from? That's where it crosses the x-axis. That's where our parabola crosses the x-axis. Please look at these and compare them to these. Compare the zeros to the factors. Whoa. Okay? This one's a little tricky. It's a little tricky because this 0 right here, look, this 0 right here comes from that factor. Let's do number 1, and I think it'll be a little clearer. Fair enough? If this is the factored equation, how do I get the expanded equation? Y equals x squared plus 1x minus 4x minus 4. When I combine my middle terms to get my expanded equation, I get y equals x squared minus 3x minus 4. Yes? So in my calculator, if I go and put in y equals x squared minus 3x minus 4, I get something that looks like that. Where is it crossing the x-axis? -1, positive 4. You got that? Good. If it crosses the x-axis at -1 and positive 4, what are the zeros? X equals -1, x equals positive 4. Now, compare the zeros with the factors. Compare the zeros with the factors. Out loud. If I give you the zeros, can you tell me the factors? If I give you the factors, can you tell me the zeros? How? It's not a secret. It's not a secret. If I say to you, this is a factor, and this is the zero that goes with that factor, how did I get there? This is the zero that goes with, this is the factor that goes with that zero. How did you get it? Several of you are saying it's opposite. Several of you are saying change the sign. Can I tell you the correct math way to say it? Because that works sometimes. The way I'm going to say it works every time. Okay? Let's turn over to number 7 and we'll write it. Okay? Because that's what number 7 is asking for. How are each factored equation related to the 0? Set each factor equal to 0 to get each 0. While I agree with you 100% that positive 4 is the opposite of negative 4, and that while negative 1 is the opposite of positive 1, that's great. But I hope you agree with me that if I say x minus 4 equals 0 and I add 4 to both sides, I get x equals 4. Or if I have x plus 1 equals 0 and I subtract 1 from each side, I get x equals negative 1. Yes? Can I show you where your way does not work? Please? Look at number 5. Look at number 5. Number 5 starts with the expanded equation, so we have to get to the factored equations to see the factors, right? This is a trinomial with a leading coefficient of 2, and I cannot divide that 2 out. So what do? What's AC? Negative 24. A times C, right? What's B? 5. What multiplies to be negative 24 and adds to be 5? Multiplies to be negative 24 and adds to be 5. 8 and negative 3. Okay? Remember this from when we factored. At this point, we have to rewrite this problem. 2x squared, what'd you say? 8x minus 3x minus 12. Right? I split my middle term into two parts. The ones that made this true. Right? Then I just look at the first two terms. What's common in those first two terms? What can I factor out? How about a 2x? What's left is x plus 4. What's common in the last two terms? Negative 3. What do I have when I divide out a negative 3 from each term? X plus 4. So what is my factored equation? 2x minus 3 and what they have in common, x plus 4. It's been like a whole week since we did it. It's okay. That is a lot of sleeping. It's okay. Looking at the factors your way, tell me what the zeros are. Positive 3, negative 4, right? Can I tell you what the factors really are? Or the zeros, what the zeros really are? Negative 4, 1.5. Can I show you how I got it? What did I say we had to do? Set each factor equal to 0. So if I set this factor equal to 0, 2x minus 3 equals 0. If I have to set this factor equal to 0, x plus 4 equals 0. Here I subtract 4, I get x equals negative 4. You guys called that one, you told me that one right. Right? Here I said this equal to 0, I add 3 to both sides, but I'm not done yet. Because I have to divide both sides by 2. What is 3 divided by 2? 1.5. Okay? That's why the other 0 is x equals 1.5. And that's why your way doesn't work every time. Okay? It works most of the time, but most of the time doesn't get you 100 on the test. Okay? It's not too late. Look at the very, very back page. Look at the very back page. For homework, you're going to do 1 through 4. Because we got there. Okay? I would like you, however, notice these are the practice problems. Turn back a page so you can see the sample problems. We're just going to talk through some of these because it's important that I make sure you understand what to do. Do I really need to do a sample problem like this? What does this want you to do? Put it in the calculator and look at the table. What are you looking for in the table? Where are you going to find your zeros? Number, comma, 0. So what we're looking for is where y equals 0. That will give you your zeros. We don't care where x equals 0, not right now. We care where y equals 0. What about b? What are we looking for here? Oh my gosh, it's exactly the same. Where we're looking for is y equals 0. What about C, D, and E? Do I have to do one of these? What does it want you to do? Graph it and look. Exactly. Look where it crosses the x-axis. Okay? I'm going to actually do C for you in just a moment because I want to show you something on the calculator. Okay? Look at F. I'm not telling you to look at your grades. I'm saying look at problem F. Sorry, I don't mean to confuse you. Okay? What are the zeros of this graph? Where does this parabola cross the x-axis? So x equals 2 and x equals -3, right? What are the factors? X minus 2 and x plus 3. You okay with that? Good. Several of you said it out loud, so I know you're understanding. There's quite a few around the room, so please help your group mates. Okay? How do I find the function? You're showing me with your hands again, right? Multiply. Y equals what? X squared plus 3x minus 2x minus 6. Okay? So simplifying my middle terms to get my final function, my final equation, y equals x squared plus x minus 6. Okay? So real quick, look at C. Actually, I'm not even going to show you C. I already have this one up on my calculator. It's the one we put in earlier. The y squared minus 3x minus, x squared minus 3x minus 4. You see that one? I'm going to show you where the x-intercepts are on this problem. Because I'm going to say menu, analyze. I'm finding my 0. It says lower bound. That means I need to put my line, my little pointer finger, on the left-hand side of that intersect. And then I click my middle button. And then it says upper bound. So I move it on the right-hand side. Whoa, did you see that? Look, watch what happens when I move it on the right-hand side. What shows up? Did you see that point pop up right there? And when I click it, what shows up right there? It says -1, 0. It tells you exactly where the intercept is. But then I have to do it again. Menu, analyze a 0, and I move it on the left-hand side of that intercept, and then on the right-hand side of that intercept, and once again, it pops up and shows me where the intercept is. Okay? What are you doing for homework? 1 through 4. Okay? If you need help, please come and see me for tutorials. I'm here every morning, and I'm here most days after school for a little while. Okay? Every morning. Even Saturday. No. I'm not really here Saturday either.